So this is part two in reference to scenario A, and this would be how I would address the problem with the students. I think firstly, just to make them realise the problem, I'd get them to subtract. I think the best one would be 0.10 from 0.8. If they are saying it's 0.2, then maybe get them to do it on a calculator, just so that they can see where the error is occurring. I think what would be important is for me to describe place values to them and how the individual digits and the decimals work, and explain the idea that kind of beyond and back on to the left and to the right of the decimal point, you're still working with one number, so the numbers can flow across that point as you would do if it was kind of 8 plus 2 and you'd go to 10, so you'd move the 1 to the left and add a 0 to the end, which is the kind of logic they've applied, but they haven't crossed it off the decimal point. And yeah, I would like to them to understand that the kind of each point, each place value has its kind of restricted value. So by changing, when you change the first number beyond the decimal point from an 8 to a 1, regardless of what comes after that, the number is being reduced. So I think kind of drawing out kind of like a 5 digits prior and 5 digits post number, and just showing them place values, having them maybe do some tasks with that, I think would be good in explaining that. In addition, you could probably use the fractions as well to maybe see it in a different form. I think that wouldn't be restricted with the same problems that place values have, and kind of just showing them that, you know, fractions, decimals, same thing, in a sense. And when you would do the same type of calculation to uh, a decimal number, it's the same rule. So doing kind of 8 over 10 plus 2 over 10, you wouldn't get 1 over 10, which is the number they produced. So I think those would be kind of the ways I'd approach teaching the students that.